Digit recognition is one of the greatest projects to start with machine learning, and there is a lot of work surrounding this topic. So, we will build our own digit recognition model and app in this video, similar to the one I'm showing you on the screen, using Python, TensorFlow, and Pygame. Without further ado, let's get started with it. Let's talk first about the project file structure. We have our main file that we will use to run the components of this project, such as training the model, testing the model, and running the Whiteboard app. We have the assets folder that has two folders in it, one called digits that we will store a copy of the whiteboard state as an image, so we can use that image to predict which digit is on it, and another folder called fonts that we will use to store the font used in this app. We also have a checkpoints folder to save the model checkpoints, so we don't need to train the model every time we want to use it. Additionally, the project contains the src folder with all the Python files for this project. I already have some stuff that we will use. For example, the fonts. I already defined some that we will use as Pygame fonts objects. Also, I have already defined some colors that we will not use all of them, but they can stay there for future projects, for example. Also, I already defined some configurations or constants that we will need when developing the project, such as the number of epochs that I want to train my model, validation split percentage that divide the data and get a percentage of them to validate the model that we will train, the screen sizes, the width and the height, and also the whiteboard size, the whiteboard that we'll place in the middle of our application to draw the digits, and the whiteboard position that I'm already making some calculations to put it on the middle of the screen or on the middle of the application screen according to the screen size constants that we declare first. I brought this function file from an older project of mine with the horizontal button displayed function, which, given a list of buttons and some proper style in the parameters, it draws the buttons on the screen. Additionally, this function adds a hover effect on the button, returning a string that represents a button from the given list. When receiving a list of buttons, this function iterates through each button in the list and checks if a mouse click event occurs hitting that button's area. If so, it selects the button based on the mouse position passed as a parameter. It also checks if the mouse is hovering over the button's area to display the hover effect. If the button is clicked, it is highlighted. And finally, the function shows the button component on the screen and returns the click button if there is one, otherwise it returns an empty string. Let's build a model script in which this file will be used to train, test, and make digit predictions, starting by importing the necessary libraries, including TensorFlow function and some of the constants that we have declared in the config file. We are going to create a class and call it digit recognition model, declare the model variable, declare the init function in which we will get the dataset. Before proceeding with the dataset preparation, MNIST is a dataset that contains 70,028 by 28 grayscale images of the 10 digits, with 60,000 for training and 10,000 for testing. Continuing with the code, next we will have to prepare the data by dividing the train set into train and validation data, and also loading the test set. After, we have to define the save checkpoint directory and define some callbacks, an early stopping function with a patience of 3 on the validation loss, and a model checkpoint callback to ensure that during model training only the best performing model in terms of validation accuracy will be saved, and it will override the previous saved model if the new one is better. Next, we will load the model if there is one saved by calling that we will implement next. We will load the model if the model file exists. If not, there is nothing to load. In the show metrics chart function, we will show two graphs, one for accuracy and validation accuracy, another one for loss and validation loss. In the function, we are just getting the model history data and using matplotlib to plot them on the graphs. We will see an example at the end when we have everything ready. In the train model function, we define the model and its architecture. By the way, we are using convolutional neural network model. We will use the Adam optimizer with a learning rate of 0.001. Afterward, we will train the model with the callbacks and the data. After it's trained, we will save the model in the directory we declare and call the show metrics chart function to show the model training evolution. In the test model function, we will use the model to evaluate with the test set and print the model's loss and accuracy. Afterwards, we will categorize the data in this set and make further predictions, getting the predicted value and the true values to build a confusion matrix with them. The rest of the code is the plot configuration to show the confusion matrix. In the predicted function, you will receive an image path that will be the whiteboard image in the digits folder inside the assets folder, and a show graph boolean value to show the image graph or not. In this function, we will check if the image path exists, read the image, pre-process it, make the digit prediction, show the image graph if requested, and finally return the predicted value. Let's build the app script in which this file will be used to run the Whiteboard app, starting by importing the necessary libraries, including Pygame, the digit recognition model that we have already made, and some of the constants that we declared in the config file. We are going to create a class and call it app, in which we will initialize Pygame and declare some variables that will be needed. We will initialize Pygame, define the path to save the whiteboard image, set up the screen, initialize the digit recognition model, create a whiteboard surface, define the action buttons, store the position of the whiteboard hitting the screen, define button dimensions and positions, initialize predicted value, and initialize mouse position. The reset board method is to reset the board to the initial state by filling it with white again, and also sets the predicted value to the initial state. The get model prediction method is to get the whiteboard image prediction from the model, but first we need to save the whiteboard image, resize it to 28 by 28 to fit the model. Just a moment to clarify this. The whiteboard is 300 by 300, and the digit recognition model that we built works with image of 28 by 28. So in this stage, I'm just resizing the image as the model receives it. After resizing it, save it and get the model prediction. The draw screen components method draws the screen components such as the app title and the whiteboard. The draw predicted value draws the predicted value and its box by calculating the box position and using Pygame regs to display the value and the box. We are displaying the predicted value only if we have one. The draw action buttons method draws action buttons. We declare the clean and predicted buttons up there in the init method. In this method, we are using the horizontal button display function. I explained it in the beginning alongside with the button styles. The check action method checks action based on button clicks. If the button click is to clear the whiteboard and predict the value, those values are going to be reset. If the click button is to get the model prediction, the app will get the model prediction and draw it on the prediction box. The run method is a method that contains the main loop of the Pygame application. We initialize the line start with to store the starting point of the line and start the main loop by getting the mouse position and updating the screen background, checking the event, set the app ending condition, check the mouse position down event. That means that the user is drawing on the whiteboard, and we are setting the line start to current mouse position relatively to the whiteboard. Otherwise, if there is a mouse up event, we reset the line start because it means that the left mouse button is released. Also, aside from the button, we are checking if C key is pressed to clear the whiteboard or P to predict the digit on the whiteboard to give more options on the app. After we are drawing the whiteboard into the screen, call the method to draw the screen components, call the method to draw the action buttons, the method checks and executes actions, and the method to draw the predicted values. Regarding the line on the board, we have to check and draw the lines only when the line start is not known or the mouse button is pressed. Get the current mouse position relative to the whiteboard and draw the line. To draw the line, we are using a smooth line function because if we don't do so, the line will be too thin and we want a larger one so the model performs well on its prediction. To do this, on the utils file, we will declare a function called smoothLine. This function receives the surface color, start position, end position, and thickness as parameters and calculates this distance and angle between start and end point. Calculate offsets from slight shifts in the line drawing, and finally draw multiple lines with slight offsets. Back to the app file, after making the smooth line, we have to set the start line width to the mouse position. Then just add the Pygame update display method and the Pygame quick method. On the main file, we need to import the libraries that we will need, such as the arcs, and also we need to import the app and the digit recognition model that we built before. First, we initialize an object from arcs parser class and add an action parameter which can be train model, test model, or app. Parse the command line arguments, initialize an object from digit recognition model, create a function called create app instance function that is to create an instance of the app class and run it for us. We need to define a dictionary mapping action that corresponds each action to a method or function. We will receive an action argument while executing this main Python file on this project, in which the possible arguments are to train the model, test the model, and app. Train and test model to execute the train model and test model methods from the digit recognition model class, and the app that will run the Python application. In the end, we are running through the actions provided while running the script to execute the selected actions based on the command line arguments. Now that everything is ready, let's train, test, and run the app, starting by executing the main file with the train model action to train the model. Keep in mind that for me, I just defined 10 epochs in the config file, but you can test it with more epochs and even build another model structure and test it for yourself. After the model is trained, it will generate these two plots that we programmed in the digit recognition model to plot the history data of the training. A plot with the accuracy and the validation accuracy, which looks just fine for me, and a plot for the loss and validation loss, which also looks fine for me. The model is trained and it saved the file for us in the checkpoints as we instructed it to. As we can see it there, now we can test the model by running the main file with the test model action to see how our model performs by checking the confusion metrics, and we can see that the model performs well by predicting the values. There were some values that it confuses with others, but that can be improved, and I leave that for you as a challenge to improve. And lastly, run the main file with the app action and test the app with some digit, and it works fine as you see, and also it has some misclassified digits, which is pretty normal. One last look at the project structure. We can see that we have the CNN model.h5 file saved in the checkpoints folder and the whiteboard image in the digits folder. And that's it to build this digit recognition model and application or system, whatever you want to call it. One future step in this project could be to build a number recognition based on this to extend these 4 digits to number recognition. Thanks for watching this video till the end. I hope it is helpful for you. If so, leave a comment. If any doubts, also leave a comment. I advise you to join us so you can see the future increments of this same project and other projects developed by us.